Good morning students, this is Junita Mukherjee from SS Public School. Today we are going to start a new topic of electric charges and fields. Here we have this particular topic of electric charge due to a point charge. Previously we have discussed about the electric field and the electric field intensity. We have here the plus charge and the negative charges, and the negative charge going outside or going inside, and for the positive charges it is going outward. So inward, so this particular radial charges, this particular radially inward, it is the electric field or the vector is directed towards inward for their negative charges, and outward towards the positive charge or for the positive charges. Electric field due to the point charge. We know that we have taken a test charge Q0. For this test charge Q0, we have this vector R given by this particular value, and we have here from the Coulomb's law derived from this particular thing. We know what is a Coulomb's law and how it is being derived. Okay, so we will talk about this electric field due to a point charge. First, you look at the blackboard here. We are taking this particular value of this O, X and Y, that is this particular value is Y, this is X and this is O. This particular thing is given as the Z direction, that is X, Y and Z directions both. This particular value is of Q0, okay, test charge, and we have here the force given by F here, and R is position vector here, okay, and we will have that point P is equals to X and X, Y and Z. Point X, Y, Z we have taken here in this particular coordinate, and now to find this particular electric charge due to the point charge, we have to find the electric field at a point P due to the charge plus Q placed at the origin such that OP is equals to R. O to P is equals to R, you know it very well. We have taken this value as R here, and we have to find the electric force on the test charge Q0 placed at point P due to the some charge Q itself. Basically there will be a charge Q, otherwise how the test charge will come. Okay, so this will be due to the source charge Q itself. According to the Coulomb's law, we know that F is equals to 1 upon 4 pi epsilon 0 Q1 Q2 upon R square, or with respect to the R value we have taken here R square and R cap, okay, and we have taken Q0, Q1 Q2 instead of Q1 Q2 we are taking Q0 because this is the source charge Q and Q0 is the test charge here, and if E is the electric field at a point P, then we have E equal to limit Q0 tends to 0, that is will be equal to from the electric field intensity F upon Q0, okay, F upon Q0, this will be equal to limit Q0 to 0, 1 upon Q0, we are taking it out, and F, we know the value of F is 1 upon 4 pi epsilon 0 Q1 Q0 upon R square R cap itself, and this will be taken again outside. If it is taken outside, what will the value? 1 upon 4 pi epsilon 0 Q R square and R cap, okay, R square R cap. This will be the first equation. The magnitude of the electric field at a point P is given by 1 upon 4 pi epsilon 0 Q upon R square itself, okay. So this will be the value of the electric point at a field, okay. So why we are taking Q equal to R square R cap? Because R cap, we know that this particular value will be given by this R square itself. So magnitude of the electric field will be given by this particular value. Magnitude, it has been given, not the vector form, the direction. And this is for because of the direction itself, because we are taking the direction here itself for the R cap, that is by vector form. So vector form we are not taking, we are taking only the magnitude, therefore R cap will be taken out, okay. So this is the main reason or the valid reason for this particular part. And for the above formula, it is clear that the electric field at any point in space due to the charge depends only on the distance, and that means that the magnitude of the electric field due to the point charge is same for all the points of the sphere, and that is has the spherical symmetry. So you have understood this particular topic, relation of electric charge due to the point charge here. Next we will move on to the electric charge due to the system of charge here. Okay, so we are taking here the charges Q1, Q2, Q3 and so on. Let us do this particular topic in the board itself, so you will be able to understand more properly and more thoroughly that particular thing. So let's see that one. Okay students, so let's do this particular topic, that is electric field due to a system of charge. Electric field due to a system of charge from the name comprises of, that is, previously we have done electric field due to the point charge, and for the point charge what is the magnitude to know it from the Coulomb's law itself very well. And consider this n point charges, that is q1, q2, q3 up to qn, and f force charges. Force will be F1, F2 up to Fn for on a test charge Q0 placed at the point origin. We know it very well. So these are the test charges. Okay, sorry, this is the test charge Q0 at the point P, and with this forces F1, F2, F3, and so on with these forces here. And this is the charges direction of the charges from Q. This one is Q2. This one is Qi, Q1, Qn, and so on. So this is the positive test charge Q0. Okay. So test charge, positive test charge we have taken here Q0 placed at the origin Q0. Now Fi is the force in the ith charge particle of Qi on Q0. So basically we are focusing on the Q0 part, that is test charge. So we are taking the ith particle of the test charge, that is Qi of this particular charge on the Q0, the test charge Q0. Okay, because we are taking a system, from the whole system we are taking, so Q0 will be the first value and then up to Qi will be the last value. So what will be the value then for Coulomb's law? It will be Fi, because we are taking the ith particle. It will be equal to 1 upon 4 pi epsilon 0 Qi Q0 R I cap R upon Ri square. Okay, where Ri is the distance of the test charge. Okay, we know about this particular distance. So Ri is the distance of the test charge here from Qi to Q0 to Qi. The electric field at the observation point P is given by the limit Ei from the intensity, electric field intensity E is equals to F upon Q0. So limit Q0 to 0 with limit Q0 to tends to 0. 1 upon 4 pi epsilon 0. Before going to 1 upon 4 pi epsilon 0, we have 1 upon Q0 as this common. We are taking common out of it, and this particular value will be given by Q upon 1 upon 4 pi epsilon 0 Qi Q0 Ri square into Ri cap. This will be equal to E I equal to 1 upon 4 pi 0 Qi, that is Qi upon Ri square is equal to Ri cap itself. Okay, we are taking Ri cap here itself, and this will be equal to E equal to that is electricity of the electric field intensity because of the point P, electric field at that point P. The system of the charges by the principle of superposition, we will have this E is equals to E1 into E3 up to En, that will be equal to sigma I tends to 1 to N, that is Ei, and using the first equation, what will be the value? E equal to sigma I tends to 1 to N, 1 upon 4 pi epsilon 0 Qi Ri square into Ri cap, or E equal to 1 upon 4 pi epsilon 0 sigma I tends to 1 to N Qi Ri cap into Ri upon Ri square, and therefore E will be the vector quantity. So for the vector quantity, what we need to take? We need to take Ri square. In the previous section we are not taking this Ri cap here, but in this particular section we are taking the Ri cap here, and we are taking this as a Qi. Why we are taking as a Qi itself? Because we are taking the whole system of the charges here, whole system of the charge, or we are taking the system of a charge itself. So system of a charge is defined by the Qi itself, so we are taking Qi here. Okay, so it is being understood right now very well, because this particular charge, this Qi and Qi to Q0 will be comprising the whole system of the charge. So in case of this, we can take it from the previous section, from the point charges. For the point charge it is Qi, so Q1 or Q2 or Q0, okay, previously it was Q0, so we can take directly I hope this made you more understand this particular topic. So we will be moving towards the electric field lines in the next topic, in which I will explain you the electric field line properties, and I will tell you the representation of the electric field line. If you have any queries regarding this particular two topics which I have explained today, you can comment in the comment section, or you can conclude in the next video. Before the next video, if you have any problem, please WhatsApp me, and I will be giving you more details about the topic. Thank you students, thanks for watching this video.